Hey, welcome to day 16 of 100 Days of Code. Now, today we're going to be pulling out the big guns. We're going to be learning about object-oriented programming, otherwise known as OOP. Why are we learning about it? Well, if you think back to yesterday's project, some of you, I'm sure at some point during the project, would have had this feeling of, what on earth is going on with my code? And the reason is because our code is getting more complex. It's trying to do a lot of things, and it's trying to manage a whole bunch of relationships. So one function is changing a variable, and then that same function is doing something else to another variable. And at some point, the logic of our code starts looking very, very spaghetti-like. And it's at this point where it's really hard to track and remember what's actually going on in our code. So this style of programming is called procedural programming, where we set up procedures or functions that do particular things, and then one procedure leads to another procedure, and all in all, the computer is mostly working from top to bottom and then jumping out into a function as needed. Procedural programming is one of the earliest paradigms of programming. In fact, back in the days when we had older languages like Fortran or COBOL, they rely pretty much exclusively on procedural programming, like what we've been doing. But the increase in complexity, the increase in number of relationships that we need to remember and manage starts making it look a bit like the dating history of the Kardashians. And it gets very, very confusing because everybody has been in touch with somebody else. Now, the kind of relationships I prefer are one-to-one, me and my couch. So how can we maintain a simple relationship in our code while being able to write more and more complex projects? Well, this is where the object-oriented paradigm comes in really handy. Now, let's imagine that you're tasked with creating the program for a self-driving car. Now, as you can imagine, this is a pretty complex project, and it's many, many notches above the coffee machine that we've been struggling with so far. But what if you broke it down? What is a self-driving car? What are the different components that make up a self-driving car? Well, it probably needs some sort of camera module to keep track of what's on the road and to recognize what's on the road. It will probably need a form of lane detection to know if we're actually within the lane or if we need to turn off or if we need to park. And it will need some way of navigating so that when the user says, I want to go to the bank, they identify the branch they want to go to, and then the navigation gets set up and the car knows how to get there. And finally, you'll probably need some form of fuel management, right? What should happen when the fuel gets low? Should it go and automatically recharge at a specified point? Now, I'm obviously simplifying this task. There's a lot more that goes into making an automated car. But we've already managed to break it down into several modules that we can think about tackling, right? But imagine if you have a whole team who are all working on this project. And within that team, there's sub-teams who are working on each of these different modules. Well, then, by splitting up this big complex task into separate modules, then we can all work on this car simultaneously, massively improving our productivity, making it much quicker to eventually build all the software for this car. Plus, on top of that, a lot of these modules are reusable. So if it just so happens that the next year we're tasked with building a drone, well, a lot of those programming modules that we built, like the camera module, the fuel management, the navigation, that's all going to be incredibly useful in our drone delivery software as well. And because we've taken out these individual chunks of code and modularized them using object-oriented programming, we won't have to code them up again in the same way that we might need to if we were using procedural programming. So what exactly is object-oriented programming? we've seen that we can split a larger task into smaller pieces. And each of those pieces can be worked on by separate teams, separate people, and also each of those pieces become reusable if we need the same functionality in the future. But object-oriented programming actually takes that concept even further. And I think the best way to explain it is to imagine that you are tasked with running a restaurant. So you take over this restaurant from your long lost uncle and you realize that it's actually really hard running a restaurant. So first off, you have to be the receptionist and you reserve seats for your restaurant visitors. And then when they order something, you have to be the waitress and bring them their order. And then, of course, the order needs to be cooked up, right? So you're also going to run into the kitchen and be the chef, create the thing that they ordered. And finally, you're also going to be the cleaner, tidying up after everybody once they've left. As you can imagine, if you're one person having to do all of these tasks, that's going to be a pretty rough day. There are, in fact, one-man restaurants, and I've seen some work really well in Japan, where you have just one person who's taking the order, who's making the food, who's tidying up after you. But the limitation here, though, is that look at how many seats he has. You can't have a large restaurant running everything by yourself. In the same way, we can't create a very complex and very large software project if we're using a procedural style of programming where we're sort of running a one-man band. It gets very, very complex and very hard to manage very quickly. So let's consider the alternative. What if we had just hired a bunch of people where they each have their own individual roles, they're trained for it, they know what to do, the waiter knows how to wait, and the chef knows how to cook? Well, in this case, you could just be the manager, and you can manage all of your staff and tell them what it is that they need to do. But then you won't have to worry about the nitty-gritty details of exactly how they need to go about doing their jobs. So for example, you don't need to tell the waiter how to wait on customers, and you don't need to tell the chef how to cook an egg because they already know how to do that. And we can use the same concept to simplify the relationships in our code and make it scalable for larger and more complex projects. We've seen a little bit of why object-oriented programming is really useful, but now let's take a look at how you would actually go about implementing object-oriented programming. So in the last lesson, we talked of this example of the restaurant, where we hired 3 types of staff, and we had a manager who would then manage all of these 3 different types of staff. Now, the reason why object-oriented programming is called that is because it's trying to model a real-world object. So let's say that we are creating a virtual restaurant. Well, in this case, we probably have to model a virtual chef, waiter, cleaner, and manager. So let's say that we were going to model a waiter. In order to model our waiter, there's probably 2 things we need to think about: what it has and what it does. In terms of what it has, well, it might have variables like, is it holding a plate, true or false? Or which tables is it responsible for? Maybe table 4, 5, and 6. Now, it also has things that it does. Maybe they're able to take an order to the chef, and maybe they also need to take payment and add money to the restaurant. So these 2 different things, what the waiter has and what the waiter does, are the 2 most important things that make up an object: its attributes and its methods. By looking at the code, you can pretty much see that the attributes is basically a variable. An attribute is just a fancy word for a variable that's associated with a modeled object, like our waiter here. Because it's not just a free-floating bit of variable, right? It's not just somewhere in our main.python. It's actually a variable that's attached to a particular object. It's the waiter's tables responsible. Now, the method goes along the same vein. These, as you can clearly see, are just functions. But we call it a method because it's a function that a particular modeled object can do. We need a waiter object to take the order, and we need a waiter object to take payment. Again, these are not just free floating functions. Now, there's a lot of new words that are part of object-oriented programming and programming in general. We're going to see them again and again, and eventually it's going to become a word that's going to be in your dictionary. But for now, just remember that in object-oriented programming, we're trying to model real-life objects, and those objects have things, and they also can do things. The things that they have are their attributes, and these are usually modeled with variables, and the things that they can do are called methods, and they are modeled by functions. So essentially, an object is just a way of combining some piece of data and some functionality all together in the same thing. But we can actually have multiple objects generated from the same type. So when we've modeled a particular job in our virtual restaurant, like the waiter's job, and we've figured out what are the things that the waiter have and what are the things that it can do, well, we can actually generate multiple versions of the same object. So we could have Henry, who's a waiter, and we can also have Betty, who's a waiter. And we can generate as many of these as we want from the same blueprint. And in OOP, we call this blueprint or this type a class. And we call these individual objects that are generated from the blueprint an object. So now let's take a look how we use these class blueprints to create an actual object. So here's a blueprint for a car. And that blueprint that specifies what the color of the car is, how many wheels it should have, what its mileage is, how much fuel it has, all of those bits of data combined with all of its functionality, like the ability to drive, the ability to stop and brake. And that blueprint, which models a real-life car, is known as the class. And it's from this blueprint, this class, that we can generate as many objects as we want. Now, the object is the actual thing that we're going to be using in our code. The code equivalent of what just happened, creating a new object from a blueprint, looks like this in Python. You have the class, which is normally written with the first letter of each word capitalized, which is known as Pascal case. This is to differentiate it from all the variable and function names that we give in Python, where each word is separated by underscores. So in this case, the car is the object, and it gets created from this car blueprint. All we have to do to create the object from the class is to give the object a name. It can be anything you want. Set it equal to the name of the class, and then the parentheses, which in the same way as it activates a function, it activates the construction of this object from the blueprint. Now, in order for us to practice this and to see it in action, we're going to be using a library of code that somebody else has created. And what it allows us to do is to finally start putting graphics onto the screen. The premise is really simple. Let's say that somebody somewhere has created a blueprint for a turtle. Now, this turtle has a paintbrush on its back, and you can tell the turtle to dip the paintbrush in different colors, pick different size paintbrushes, and most importantly, you can tell it to draw onto the screen. This library is called Turtle Graphics, and it's preloaded with every download of Python. So we can get started with it straight away. So go ahead and open up PyCharm and create a new project. Now I'm going to call mine by the old convention, day 16 start, and making sure that I'm on the latest version of Python in my base interpreter, I'm going to click create. Now once you've created the new project, go ahead and create the main.py as we have always done. In our case, we're going to be creating an object from a blueprint that somebody else has already created. And the blueprint lives in another module called Turtle. So we'll have to import that module. And we know that from previously, we can import other modules and use the things that are declared inside the module by importing it and then tapping into various things in there. So for example, if I was to go and create another new file, which I'll call another module. Now inside another module, let's say I create another variable. And now I can go back to my main.py. I can import my another module I just created, and I can tap into that variable that's inside another module by saying another module dot another variable. Now let's go ahead and run this code as it is. And you can see the value of that variable from the other module being used inside our main.py. Now, I want to do the same thing using turtle, but in this case, I want to tap into the class called turtle that's declared inside this turtle module. The wording is a little bit confusing, but let me show you what I mean. So I'm going to tap into the turtle module, and I'm going to get hold of a turtle class. So notice how it's got the C here, denoting that this is a blueprint for creating a new turtle object. Now remember that to actually construct the object, we need to add the parentheses at the end. And now we can save all of this into an actual object which we get to name. So I'm going to call my turtle Timmy. And now I've got a new turtle object. Essentially, we've done the same thing as we have done up here. We've imported a module called turtle. We've tapped into that turtle module here, and then we've fetched something from that module. In this case, it's a variable, and in this case, it's a class, which is denoted by the capital T, the Pascal case here. And then we've used the parentheses to initialize, or basically construct, an object from that blueprint, and we've saved it into an object called Timmy. Now I can simplify this code to make it look more like what we had in the slides by saying, instead of import turtle, I can say from the turtle module, import the turtle class. So now, instead of writing all of this, I can simply just write Timmy equals a new object created from the turtle class, and it's constructed. This is how we would construct our new object. So now I have this brand new object called Timmy. And if I go ahead and print Timmy, you can see that when I run this code, what gets printed is a new turtle object from the turtle module, and it's saved at this location in the computer's memory. So this is very different from, say, if we just printed a string or a number. It works completely differently. In this case, it's actually an object that's being printed. Now, what can we do with this object? Now, as we saw before with our car object, it has certain attributes, right? Like speed and fuel, data that it could keep track of that are really important to the modeling of an actual car object. Now, when it comes to accessing these attributes, the syntax or the code looks like this. Car in this case is the object, and then we use a dot or a full stop to separate the object from the actual attribute that we want to get hold of, which in this case is speed. What this code does is it essentially identifies the object and then says from this object, get the speed attribute. This is actually going to represent the speed of this particular car object. Coming back to our turtle, one of the other classes that is inside this turtle module is something called a screen. And the screen represents the window in which this turtle is going to show up. So let's go ahead and create this screen object. I'm going to call my object my screen, and then I'm going to create it from this blueprint of a screen that we imported. Now we can tap into one of the screen's properties, which is called the canvas height and canvas width. So let's see what the height is. And notice how we're using that dot notation. So this is the object, and then separated by a dot, we've got the attribute that we want to access from this object. So I'm going to print that into the console. Now, when I go ahead and run this code, you'll see a window pop up very briefly. And that was the screen on which our turtle is going to show up. Now, if you take a look in the console, you can see that not only have we printed the turtle object, but we've also printed the height of the canvas for this particular screen that we've created. So the screen here is the object, and that canvas height is an attribute that's associated with that screen. Now, in addition to the things that an object has, so data that it holds, like the speed or the fuel, which we've already seen, it also has things that it can do, right? So functions that are associated with that particular object. And these functions, when it's tied to an object, is known as a method. But essentially, we would use it the same way as we have done with any other function that we've created so far. The only difference is the syntax. Firstly, we would tap into the car object, and then using that same dot notation that we saw with the attributes, we're saying car dot stop. So essentially what we're doing is we're getting hold of the object, and then we're calling this function that's associated with that object, which is known as a method. So coming back to our code here, one of the things that we can do with this screen object that we've created here, called myScreen, is we can tap into one of its functions. And because it's a function that's tied to an object, it's actually called a method. So the method name is called exitOnClick. And what this will allow us to do is, instead of having our screen show up and then quickly disappear when our code ends, this exitOnClick will allow our program to continue running until we click on the screen, and then it exits our code. So let's try this again. And notice how we've now got our screen show up, and this canvas has a height of 300 and a width of 300. But now we can see our turtle in the form of the arrow. So this is our little Timmy shown up in the middle. And our code is only going to exit when the screen detects a click, because we've called this function that's associated with the screen object. So now if I click on the screen, you can see process finish with exit code 0. Our code has ended and the screen has disappeared. Now there are other functions as well. So if we take our little Timmy object, and we say, well, Timmy, why don't we change the shape of you on the screen, and we'll change you into an actual turtle. So now when I run the code, you can see that our object in the center is now in the shape of a turtle. Now, if you want to know how I know about all these things that I can do with the Turtle Graphics library, then of course I'm getting all of this information from the documentation. So in the course resources, you'll see a link to this Turtle Graphics documentation, and it tells you all the things that you can do with your turtle. So for example, you can call all of these methods that are associated with your turtle object to get your turtle to move and draw. And you can also use it to change its position or change its coordinates, as well as doing things like changing the color or resetting. And you can browse through this list to see how you would use each of these things. So for example, if I wanted to change the color of my turtle, I can do that by simply just calling this method color, and then inside the parentheses, I pass in the argument of the actual color string. Now you can choose from a whole range of colors just by putting in the name as a string into that method, which is called color. So go ahead and see if you can change our turtle Timmy's color from the default, which is just black, to one of the colors that you see in this link here. And the link, of course, is in the course resources. So let's say I want to change it to a coral color like this one. All I have to do is tap into my object, which is called Timmy, and then call the method, which is called color, onto it. And you can see all the methods are denoted by a little M here in the circle. Now, this color, of course, expects some sort of input. So the input that it expects is an actual string of a color. And my string is going to be coral, which I picked up from here. So now let's run our code and see what it looks like now. Once the screen refreshes, you can see that our turtle is now a nice coral color, and we've managed to do all of this to change the shape, change the color, all because we were able to call these functions which belong to this object. Now, see if you can use the documentation here and figure out how to get the turtle to move forwards by 100 paces. Pause the video and try to complete this challenge. Alright, so we saw earlier that it has a whole bunch of move and draw methods. So we can simply use this forward method to get it to move forwards. And in terms of the parameters that it takes a number which is going to determine the distance that it's going to move forwards by. So we said that we wanted our turtle to move forwards by 100 paces. All I have to do is specify the object that I want to move, which is Timmy, and then call that method forward and pass in the distance. So I said 100 paces. So now let's run our code again. And you can see that little turtle just move forward by 100 paces. So now we've seen how to create a new object from a blueprint. We've seen how we can tap into its attributes by using the object name dot and then the name of the attribute. So this is the same as having a variable that's associated with that object. And finally, we've seen how we can call methods that are associated with the object. For example, here when we change the shape, or when we change the color, or when we told it to go forwards. Now in the next lesson, I'm going to show you how you can get hold of more external libraries, not just Turtle, but a whole world of packages that you can tap into, and you can start using these packages of code that other programmers have already developed, and simply by creating objects from the existing blueprints and reading the documentation to get it to do various things that you want it to. So for all of that and more, I'll see you on the next lesson. Now, I've mentioned a lot about using code that other developers have written, and the most common way to do this is through using packages of code. In this lesson, I'll show you how to integrate an existing package of code into our project so that we can practice creating objects and working with attributes and methods. Now, we've seen modules of code where each file that we create in our project is essentially a module in itself. But a package differs from a module in the sense that it's actually a whole bunch of code that other people have written. Lots and lots of files all packaged together to achieve some sort of goal or purpose. Now, let's say that we wanted to create a table of Pokemon and their type. So we wanted some way of documenting that Pikachu is an electric type and maybe Squirtle is a water type. Now, if we wanted to do that in ASCII so that we could print it in the console, well, then we would have to go about formatting it, and it'll be quite painful. So we might have to print some sort of pipe, and then maybe we would have the name of the field, so Pokemon name, and then maybe another pipe, and then we would have the name of the next column, which is their type, and then finally we would close that off. And then we would have to print some sort of horizontal line, maybe like this, and so on and so forth, just to create this table. And it's quite difficult if you're not used to manipulating ASCII and visualizing it. I certainly am not up to this task. So what could we do instead? Well, we could search for a package that other developers have created to achieve this goal. And the place that we would do that is somewhere called PyPy, which is the Python package index. And this is a bunch of software for the Python programming language that is developed and shared by the Python community. So we can see their source code, but more importantly, we can see how to implement the code and how to put it into our project. In here, I'm going to search for something called pretty table. And this is a very simple library that is going to help us to display tables in a ASCII format. We can click on the project links to find out more about it. And this will take us to the Google Code Archive, where the documentation is hosted. If you go to wikis and go to tutorial, you'll see some documentation on how to use it. Now, this particular package is not as extensive as the Turtle graphics package, so there's actually not a lot of things you can do with it, but it's got more than we need for our use case. The first thing we have to do is to install this package into our project. Now, unlike the Turtle package, which is already preloaded with every copy of Python, in order to use the packages that you find in the Python package index, you actually have to install it. So here's how we do it in PyCharm. First, go to the Preferences. So in Windows, I think it's under File and then Preferences. On Mac, it's under PyCharm and then Preferences. And then here, you'll see a whole bunch of things you can change, including the editor or appearance, which we've already messed around with. But I want you to click on your project. So my project is called Day 16 Start, and then we're going to go into the project interpreter. And here we can click on the plus button to install any package that you find in the Python package index. Make a note of what it's called. So ours is called pretty table, and then we're going to search for it inside the available packages. And once we've found it, we're going to select it and then click install. If you're working with Replit, you can also install packages just by going to the Packages tab and then again searching for pretty table. Once you've clicked on the package you want, click on the plus button to add it to your project. Now, Replit is a little bit weird because it says installing, but it never actually confirms the success. But once you click run, everything will go through and it will work perfectly, as long as you see it in your list of packages here. Now, if you want to remove the package, you can simply click on the minus button, but now we're going to work with it. So now it's installed successfully. We can go ahead and close this down and click OK. And we can now access this package called pretty table in our code. Again, I'm going to import it. So I can say import pretty table, and now I can use everything that's inside this package. Now, if you want to see the source code, you can actually right click on it and select go to implementation. And this will take you to the Python file where this entire pretty table is implemented. So all the code that they've written. It's a little bit daunting and it's got a lot of code in it, but we don't have to worry about how the code is created and how it works. All we need to do is look at the documentation for this package and see how we can implement it into our project. Now in the next lesson, we're going to get some practice constructing a pretty table object and using the documentation to explore this object's attributes and methods. For all of that and more, I'll see you there. In the last lesson, we added an external library to our project. Now it's time to construct a pretty table object and practice using its methods and attributes. Our starting point, as always, is the documentation. Here you can see how to construct an actual pretty table object. So let's use what we've learned previously about constructing objects to go ahead and create this object from the class. Now, firstly, we're going to do the same thing as we did previously with Turtle. We're going to tap into the package pretty table, and then we're going to import the pretty table class, noted by the C here. Now that we have access to this class inside our code, I want you to go ahead and create an object from this pretty table class, and the object should be named table. So pause the video and give that a go. All right, so we said our object is going to be called table, and then we're going to construct it from this class called pretty table. So we're going to put it in with its casing. So this is the Pascal case that we spoke about earlier on. And then in order to actually give it the go ahead and construct, we have to add the parentheses at the end. So now you've created a new object called table from this pretty table. And we can actually go ahead and print this table. And even at this stage, it's already going to start printing out a bare bones version of a table. But of course, this table has no data. So it's actually kind of hard to visualize what all of these ASCII characters are doing in an empty table. But no matter, the next thing we can see in our documentation is how to go about adding columns. So it's got this method. Remember, methods are functions that are associated with an object. And this method will add columns to whatever table we specify. Now, the method takes two inputs. One is the name of the field. So our field names are Pokemon name and type. And then we've got a list of strings, which is going to be the data that's going to go into that column. Essentially, every time we call that method add column, it's going to allow us to give a field name as a string and then a list of data in order that they're going to go into the table. So we're going to add our table one column at a time. Using that documentation, see if you can add both of these columns to our table object. And then once you've done that, we're going to print the table object again, and we should be able to see an ASCII table. This is what you're aiming for when you run your code. It should print out your table and nicely format it in this ASCII style. Pause the video and complete the challenge. All right, so we've got our table object, and remember that methods are functions that are associated with the object. So we say table object dot, and then we get to call that method add column. And notice how it takes two inputs, the field name and the data that's going to go into the column. So the field name is going to be a string, and this is going to be the name at the top of our column. So in our case, it was called Pokemon name. And then after a comma, we get to put in a list of all the data that's going to go into our column. So just as a quick reminder, our first column contains Pikachu, Squirtle, and Charmander. Now we should have added a column to our table, and you can safely ignore all of these typos because, of course, Pokemon names are not real words. But if you wanted to check against the Pokédex, you can actually go to this link in the course resources and you can see how each of these Pokemon are spelt. Now, the next thing we want to add is the associated type with each of these Pokemon. So for example, Charmander is a fire type Pokemon, Squirtle is a water type Pokemon, but essentially we're going to add the data that's in this second column. So the field name is called type, and then we've got three pieces of data that's going to need to go into the list in the same order as the previous Pokemon. That way they'll actually match them up properly. So if you haven't already, go ahead and add the second column. So again, I'm going to call the same method on my table, and this time I'm going to add the field type, and the data is going to go in the order of the data that I had from the previous column. So the first one is the type of Pikachu, which is electric, and the second one is the type for Squirtle, which is water, and finally we've got fire for Charmander. So now this will be matched to this will be matched to this, and so on and so forth. If we go ahead and print our table now, so if we run our code and take a look in here, you can see how we've now got a nicely formatted table by creating an object from this pre-made pretty table class, and we've now called this method add column to add two columns, and when we print our table, it's now nicely formatted in ASCII. Now remember that we can also change the object's attributes. For example, if we wanted to change the appearance of our table, that's probably controlled by an attribute. if you scroll down, you can see that we can change the table style by tapping into each of these attributes. For example, if I wanted to change the alignment of my data in the table, I can change this align attribute to L for left align, C for center align, or R for right aligned. Do you remember how to tap into an object's attribute? If you do, go ahead and see if you can change our table from center aligned by default to left aligned. Pause the video and try to complete that challenge. So again, we're going to tap into our table object and we're going to use the dot notation, but this time, instead of accessing a method associated with the object, which is of course denoted by the M, we're going to access an attribute, or in this case, they've titled F, which is a field. And the one that we want is this align. So let's go ahead and type align, and now we have access to this attribute. Let's see what happens if I go ahead and print this align attribute. You can see that for both of my columns, Pokemon name and type, the align attribute is set to C, which is centered. What I want to do is change the whole table to be left aligned. Just as we would with any other variable, we can of course print it, but we can also change it. And we would change a variable by just using the equal sign, right? So let's change the alignment to left aligned. And now let's run the code again. And you can see now both of my columns are now aligning with the left-hand margin. So we've seen how we can use attributes like the ones here to change the styling of our table. We've seen how we can use methods like add column or add row to work with this table object and get it to perform some sort of functionality like adding pieces of data to it. And we've seen how we can create new objects by simply constructing it from the blueprint class. Feel free to mess around with Pretty Table as much as you like, change other things about it or add different pieces of data. But once you're happy with creating the object, changing the attributes, and calling the methods, then head over to the next lesson where I've got a quiz for you. Now you should have PyCharm up and running, and we're finally ready to tackle today's project, which we're going to write in PyCharm. You've just been hired, congratulations. But first, there's the matter of coffee. We all know that programmers can't work unless they're loaded up on coffee. So your company has asked you to create the code for a coffee machine. Now, you very cleverly go online and look at the other coffee machines, and you notice that it only costs $230 to buy a coffee machine. But you're not going to cheat. You're going to create everything from scratch. And luckily, we don't actually have to build the hardware because we're programmers, right? But we're going to use this real-life coffee machine as the inspiration for our virtual coffee machine, noting the features and the capabilities. So what does it say? I found some wonderful graphics on here, which tells me that there are 3 hot flavors, which I'm guessing are these 3 buttons. It's coins operate, which I think they mean it's coin operated, and there's not much else that it can do. Let's take this example and we're going to make a digital version of it. We're going to create our own coffee machine. And the first step we need to replicate is the ability to make 3 hot flavors. So the flavors we're going to make are 1 espresso, 2 latte, and 3 cappuccino. Here are the recipes for these 3 types of drinks. Each of them requires a different quantity of water, a different quantity of coffee, and a different quantity of milk. And they also each have a different price. We're going to be modeling all this data in our coffee machine program as well. But luckily for you, in the starting code, I've already included all of this data inside a dictionary, so you don't have to remember this. Although it might help if you're at home and you decided that you really wanted a latte instead of your usual black coffee. Now, in addition, the coffee machine has some resources that it has to manage. So it starts out with 300 mils of water in the tank, 200 mils of milk, and 100 grams of coffee. The second feature of our coffee machine is that it's coin operated. So we're going to be using American coins. And they have 4 types of coins: the penny, the nickel, the dime, and the quarter. They used to also have the dollar as a coin, but a few years ago they stopped minting that, so we're not going to count it, and it probably means one less if statement for us. Notice what each of these coins are worth. The penny is worth a cent, the nickel worth 5 cents, and the dime 10 cents, and the quarter is a quarter of a dollar. These represented in decimal values would look something like this. Now here's the important part. Let's think about what our program requirements are if we break it down. 1, we need our coffee machine to be able to print a report. It needs to be able to tell us what resources it has left, how much water it has left, how much milk, etc. If you head over to the completed version of the coffee machine, the link is in the course resources, and you can go ahead and try out the final version of the coffee machine. So let's say that we wanted a report on all the resources that the machine has. All we have to do is type report, and we can see all the resources we have. Now, in addition to being able to print a report, we also want to be able to check that the resources are sufficient when the user orders a drink. Now, let's say that the user decided to order a latte. It asks me to insert some coins, and then it gives me the change and it gives me the latte. But now if I check the report, I can see that I've only got 100 mils of water left. And I know from the previous slide that a latte and a cappuccino is going to need more than that amount of water. So let's see what happens if I go ahead and order a cappuccino. It says, sorry, there's not enough water. So our program is able to look through all the resources that the machine has, checks it against the recipe of the drink that we're trying to make, and tells the user if there is insufficient water or if there's insufficient milk. And as long as one of the resources is insufficient, then it can't make the drink, and it gives the feedback to the user. Now, as you saw before, our program also needs to be able to process coins because our machine is coin operated. So no fancy contactless payments or pay with your Apple Watch, none of that. We've only got coins. When we order something, it should ask us to insert coins, and it's going to ask for the quantity of each type of coin. So let's say that I insert one of each. Then in this case, there's actually not enough money to cover my drink, and it refunds the money and doesn't give me a drink. But on the other hand, if I do insert enough money, then it should be able to calculate how much money all of these coins are worth, and then calculate the amount of change based on the cost of my drink. And then it should hand me my drink and tell me to enjoy. So in addition to being able to process the 4 types of coins, calculating the actual monetary value based on the number of coins, it should also check that the transaction is successful, that the user didn't try to hoodwink us by not giving enough coins and asking for a drink. So if they haven't inserted enough coins, then we're just going to refund them and tell them, sorry, that's not enough money, and not give them their drink. But if the transaction was successful, then we're going to make the coffee, and in the process of making the coffee, we're going to have to deduct the resources. Notice how every time we make a drink, say in this time we made a latte, and previous to the latte, we had 300 mils of milk. But after the latte, when we asked for the report, you can see that the water has been reduced, the milk has been reduced, the coffee has been reduced, and the money has been put into the coffers. This program, even though it seems simple, just a simple digital version of a coffee machine, it actually has quite a few requirements. So I recommend that you look at this screen and try to see how each of the requirements work by having a play around with the final version of the code. Now, I've created a detailed program specification for you as a PDF file, which you can download in the course resources. And this goes into a lot more details on each of those points. For example, what should the prompt print in the beginning of the program, and then how to turn the machine off, how to print the reports, and how each of those points should work in detail. Go ahead and download this and make sure you read each of the sections and test it out in the final working version of the project. Once you're ready, you can go ahead and head over to the starting version of the code. And again, I'm sharing this using Replit, but I want you to copy everything that's in here. There's only one file, the main.py file. And I want you to create a new project using PyCharm and call it Coffee Machine. And then create a new file inside your project called main.py. And then paste all of the starting code into your main.py. And now you're going to code inside this file. And once you're ready, you're going to click run and you'll be able to run this main.py down here. And this will act as your console. Now, one really handy feature of PyCharm is something called to-do tracking. Whereas previously in Replit, I've been creating to-dos and you've been able to view them. But if I had lots of to-dos in different places, you can't actually see all of them at once. You have to scroll through the file looking for them. But in a professional tool, we actually have something called to-do tracking. And it's a tab that's down here. So if I go ahead and take some of these program requirements, I can put them in as to-dos. To create a to-do, you have to follow the syntax. First is a £, and then we write to do in all caps, and notice how that's just changed color just now. And now you can see in the to do tab, it's found one to do item. Now we can write to do number 1, and this is to print a report of all the coffee machine resources. Now let's say that I created a to do somewhere else, right? Like all the way up here. Check that the resources are sufficient to make the drink order. And notice how they're completely in different places in a different order, but every time I create one of these to-dos using this format, it will get picked up in the to-do tab. And you can go ahead and see where they live. So it's found 2 items inside our main.py, and you can see that this one is to do 1, this one is to do 2, and when you click on them, they'll take you to the correct places in your code. Use this to break down the problem into smaller problems that you can solve one by one, just as you've done before, and try to see if you can complete this project. Just a word of warning, this project is quite ambitious, but you've now got professional tools to help you, and you've got a lot more skill under your belt. So give this problem at least an hour to work on it and make sure that you satisfy all the criteria that's set out in the program requirements, and also that your program works exactly the same as the final version of the coffee machine. Now, as we start using objects and their attributes and methods more and more, we're going to start to see why it is that they are so useful and so loved by programmers. Now, I think one of the non-programmers that explained OOP the best is actually the late Steve Jobs. And he has this brilliant example that makes it really clear why objects are so great. In his story, he talks about this concept where, let's say you were traveling to Japan, and after a long flight, you finally land and you go outside and there's beautiful cherry blossoms, Mount Fuji's looking wonderful. But unfortunately on the flight, you had soiled your t-shirt. You were overly eager with the tomato juice and you spilled everything on yourself. So what do? Well, you're in this unfamiliar city and you have no idea even where the hell you are, let alone where to find the nearest dry cleaners or laundrette. And plus, on top of that, you don't have the local currency, they take yen, but you only have pounds, and you don't even speak Japanese. So what do? It's gonna be a real struggle trying to solve this problem. Well, you're staying at a hotel, right? And the hotel staff probably speak English. So you go to the receptionist and you tell the hotel that, hey, my t-shirt is soiled and they say, hey, no problems. We'll take that from you and we'll go and handle all of that messy stuff. We know how to find the dry cleaners, we can pay them in the local currency, and we speak the local language. And what you get back is just a nice clean t-shirt. So this is similar to the process of working with objects. Essentially, if you have this hotel object, which has a blueprint for how to handle dry cleaning some sort of clothing, then all you have to do is just get the object hotel and then call its associated method dry clean, and then it will do all of the messy stuff for you. And you don't have to worry about the implementation of this function at all. So now you can work with multiple objects, getting them to do different things, and trust that they know how to manage their data and how to perform the necessary functionality. Coming back to a problem that we've already solved, creating that coffee machine with all of the program requirements, well, it's time to put our object-oriented programming knowledge to the test, because we're going to be making a OOP version of our coffee machine. Now, the program still has the same requirements as before. You have to print reports for all the resources, you have to check the resources are sufficient, process coins, check transaction is successful, and finally make coffee. But in this case, you're going to be working with objects. In the course resources, you'll find a link to the starting project for the OOP coffee machine. So if you head over to this link, you can see that there's a whole bunch of code that we've already written for you. Now, the idea here is you're not going to touch any of these other files, the money machine, the menu, or the coffee maker. All of that code has already been written for you, and it's almost like you're working with an external library. You're just going to trust that they do what they say they do. And you'll find a link to this coffee machine documentation that I've created, which describes in detail what each of these classes or blueprints allow you to do. So once you construct an object from the menu item class, then you have access to the name attribute, the cost attribute, ingredient attribute, and there's also descriptions of what it should do and what an example might be. You have access to all of these classes, and you can build objects from each of these classes to solve this project. In order to work with PyCharm, all you need to do is to download the zip file with all the starting code from our course resource website. Alternatively, if you're already logged in on Replit, simply fork the project and then click on these three dots to download the zip file here. Now, once you've found that in your downloads folder, all you have to do is uncompress or unzip it. And then you can go into PyCharm and open it here. So click on the open button and then navigate to where you had that folder downloaded. Remember, it needs to be unzipped. If you're on Windows, right-click the zip file and choose Extract All. Then click Extract. You should see an unzipped folder pop up next to your zip file. If you're on Mac, then all you need to do is just double-click on the .zip file. Now if we click Open on that folder, then it will open up this project, and when you open up the project folder, you'll see all of the same files. Now you're only going to be working from the main.py. In fact, I don't even want you to care that much about the code that's in the other files. It has class definitions and a whole bunch of other things that we're going to learn about in the next lesson. But for now, I want you to treat it as if it is an external library, which you're just going to use. At the very beginning of the main.py file, I've already imported all 4 classes that you're going to be using: menu, menu item, coffee maker, and money machine. Now, all of these classes are documented in the coffee machine documentation website. All you have to do is head over to this website and read through what each of the classes do. Some of them have attributes and methods, others just have methods. So each of these classes have already pre-written code that do a lot of the heavy lifting and all of the code that we had to write when we wrote the coffee machine code from scratch. But this time, you're only going to be using these 4 classes and the objects created from them in order to achieve exactly the same goals as before. So while the goals are fresh in your mind from the previous day, you should review the code from the previous day and then have a read of the documentation and see how you would implement exactly the same project, but this time using only the objects created from these classes. You'll need to spend some time on this because you'll need to think through how to create objects from these blueprint classes and then how to use the objects, how to call the methods, and the logic that's required to put everything together. Pause the video now, have a think about this problem, and try to make the coffee machine do exactly the same and have all the same functionality as the coffee machine that you created in yesterday's project. If you got stuck or if you had any problems completing this project, the first protocol is to review the lessons you learned today. It might just be that you need to see some of the theory a few more times and listen to it a few more times and practice it a few more times before you're ready to tackle this final challenge. But if you have completed it and you just want to see the solution, then I'm going to go through it with you right now. Again, we're going to complete all of the program requirements step by step. So the first thing is to print a report for all of the current resources in the coffee machine. Back in PyCharm, I'm actually going to collapse this entire project folder because I'm not going to be writing any code other than inside main.py. Now you can see up here, we've got access to 4 classes. And if we take a look inside the documentation, you can see that both the coffee maker class and the money machine class have a method called report. And this is going to print a report of all the resources like water, milk, coffee, and this is going to print a report of the current profit. So our final report is going to be both a report from the money machine as well as the coffee maker. Let's go ahead and start off by creating some objects from these classes. For example, the money machine is going to be just called money machine, or you could call it my money machine. You can actually name your objects anything you like. But I'm just going to use the default Python snake case to create a new variable money machine, which is going to hold my object. And my object is going to be created, of course, from the money machine class. And the construction happens when I add the parentheses. So now I have an object created and stored inside this variable money machine. Now, if I want this money machine to create a report, then all I have to do is tap into the object and then write a dot and then call the method that I need, which is report. So now if I go ahead and run my code, you can see it prints out the current amount of money in the machine. Now let's do the same thing for our coffee maker. Again, I'm going to call it coffee maker, and you see this frequently. The object naming tends to be the lowercase and snake case, so separated by underscores, version of the name of the class. So the name of the class is coffee maker, and usually you'll see people name the object exactly the same, but in lowercase. And now that I have my coffee maker, then I can go ahead and call the report method on that object as well. And now if I run my code once more, you can see that I've got everything now being reported and printed out. So in this case, we don't actually have to care how report is implementing all of this functionality. All we have to do is read the documentation, find the method that does the thing that we want, and then trust that it will carry out the functionality as described. Now that we've completed step 1, the next one is to check that resources are sufficient. My first protocol is going to be going over to the documentation, and you can see that the coffee maker class actually has a method called isResourceSufficient, and all we have to do is pass in the drink, which is a menu item, and then it's going to check and give us true if that drink order can be made and false if the ingredients are insufficient. So how do we get hold of this drink menu item to pass over to this method? Well, if we take a look at the menu class, you can see it has a method called getItems. And this is where you really see reading the documentation properly, actually absorbing everything that's in here becomes really, really helpful. This menu class has two methods that are really useful. One, it's able to get a hold of the names of all the items that are available on the menu, and it returns it as a string separated by forward slashes. It's also able to find a drink based on the order name. So if we passed in one of these names to this function find drink, then it's going to return a menu item object if it actually exists. Otherwise, it's going to return none. We're going to need both of these in order to ask the user what they want. Let's go ahead and set up our while loop. As we had previously, I'm going to create a new variable called isOn, and it's going to start off being true. And then while coffee machine is on, well, then we're going to get hold of all the options that we can offer the user. And we get that by calling that method getItems. But of course, because this is a method, it's associated with an object. So we have to create an object from this menu blueprint. So let's do that next to all the other objects being created. So let's create a menu object, and it's going to be created from the menu class, and then we add the parentheses, and now we have access to that object by the name menu. The options are going to be equal to the menu object, and then we're going to call the getItems method. And then when this method returns, it's going to save the string of all the options into this variable called options. Now we can get the user's choice by asking them for what would you like? And then inside a set of parentheses, we'll offer them all the options. And then, of course, I need to turn this into an F string, and the code highlighting immediately tells me that this is actually now working. So once I've got the user's choice, then I can incorporate the reporting behavior into this choice. Remember, previously we said if the choice was equal to off, then that means the isOn is going to be equal to false. And elif, the choice is equal to report. Well, in this case, we're going to get the coffee maker and the money machine to make their reports into the console. Finally, we're ready to tackle the next problem, which is how do we check that we have enough resources? And this is going to require us to find the drink, giving the order name that the user chose from the choice, and then get hold of the menu item, which comes as the output from this method call. So else, we're going to save our drink as a variable called drink, and then we're going to tap into the menu dot find drink. And find drink, you'll notice, takes a order name as the input. So this is a string, and this is going to be equal to whatever the user chose inside this choice. So let's put the choice in here as the input. And now, once we've got hold of this drink, let's go ahead and print it. Remember, we're expecting a menu item object at this stage. So let's click run. And let's make sure that we can hit report to get the report. We can say off to switch off the machine and exit the code. And we can also get hold of a latte by passing in latte as the drink that we want. And we now get printed a menu item object at this particular location in the computer's memory. Perfect. Everything is working as expected. Now, instead of printing the drink, I'm going to tackle this step 2, which is to check that the resources are sufficient. Again, that's going to require us to look through our documentation, and you'll see that the coffee maker class has that method, is resource sufficient, and it expects a menu item object as the input. And then it's going to return true when it can be made and false if it can't. So let's get hold of our coffee maker object and then get it to check if the resources are sufficient to make the current drink that we're interested in. And let's go ahead and print the results here and run our code. Let's say that we wanted to make a latte. That's going to be resource sufficient, so true. Espresso, also true. And a cappuccino is also true. So we can make all three drinks basically. Now, instead of printing this, what we want to do is we want to check this is true and then proceed to the next step if there are enough resources. Now, the next step is to take payment from the user and to process the coins and check the transaction is successful. Notice how in our coffee machine documentation for the money machine, we don't actually have a way of processing the coins. But what it does have is it allows us to make payment, passing in the cost of the drink, and then it will return true when the payment is accepted or false if insufficient. So let's see what happens if we actually try to make payment. Let's tap into our money machine object and then call the make payment method, and we have to pass in the cost of the drink that the user ordered. So we've got the drink object here, which remember is a menu item. And each of the menu items have three attributes that we care about: the name of the drink, the cost of the drink, and the ingredient list. So this is what we're interested at the moment. So we can pass in the drink.cost, which is the attribute that's associated with the drink object, and that cost is going to be processed by this make payment method from the money machine. And then finally, it's going to tell us whether if this was successful or not. So let's see what happens when we run this code as it is. Let's say I wanted a latte. Notice how it's asking me to insert coins. How many quarters, how many dimes, how many nickels, and how many pennies. As the coffee machine, I don't actually need to care about how the money and the coins are processed. All I had to do is call make payment and it deals with all of this automatically. Finally, it gives me the change and it returns true, telling me that this make payment was indeed successful. If you actually look inside the money machine code, then you can see that it has a method called process coins, but it's called when make payment is triggered. This class is going to process the coins and then it's going to decide whether if it was successful or not. And if it was successful, it's going to add the cost to the profit. And if not, it's going to tell you that that was not enough money and your money is refunded. Coming back over here, if this is successful, then that means the user has managed to pay. And we fulfilled step 3 and 4 just using one method. The final thing we have to do is to actually make the coffee. And that, of course, happens right at the end here. And all we have to do to make the coffee is get hold of the coffee maker object and then call the make coffee method. And we can pass in the order, which is our drink. Because remember that the make coffee method expects a menu item as the input parameter. We can actually simplify this code even more by saying, well, if the coffee maker is resource sufficient and the money machine was able to take payment, well, then we can get the coffee maker to make coffee. So now let's go ahead and run our code. And let's report to begin with, see how much resources we have to begin with, and then let's order a coffee, insert lots of money, and we've got our coffee back. So now let's go ahead and order a different coffee, latte, and let's go ahead and insert lots of money, and you can see here's my latte. But now if I hit report, you can see that the objects, the coffee maker has been managing our resources and the money machine has been managing our profit. Now, if I decided to order another latte, then it should actually tell me, sorry, there's not enough water and there's not enough milk. So it can't make me that drink. And we've managed to achieve all of this functionality by writing very few lines of code. And the code itself is actually very, very easy to understand. So if you find this line difficult, then you can actually just simplify it to make these onto separate lines and save them into individual variables. And then you can check, is enough ingredients and is payment successful? And if both of these are true, then go ahead and make coffee. You can see that this code is very easy to understand, even if you came to this completely fresh. You've never seen how each of the methods are implemented. You don't know how the coffee maker works. You don't know how the money machine works. You can see quite easily what it's trying to do. And so if you only had to write this kind of code, then it would make it so much easier to create even more complex functionality in your coffee machine, right? So have a play around with these classes, the coffee maker, the money machine, the menu item, etc., and see what else it is that you can do with this code while not touching any of the blueprints for each of these classes. Now, in the next lesson, I'm going to be showing you how to create your own classes so that you can actually start structuring your code using full object-oriented programming. And we're going to learn about these things like the initialization and how classes are declared and why there's all this self all over the place. That's all yet to come on tomorrow's lessons.